Okay, so this is going to be the first section in Chapter 1, 1.1, Lines in a Plane. Alright, so the first thing we're going to talk about is something that you've been hearing about, since 7th, 8th grade, slope. Which we know is the change in y over the change in x. You can also write it as delta y over delta x, which means the same thing, change in y over the change in x. We also know it as the rise over the run. Most importantly, though, we know the formula. M equals y2 minus y1 over x2 minus x1. Okay, this is something that you should remember from many, many, many math classes. If you don't, though, you need to make sure you memorize it. Okay, so there's 4 types of slope. There's positive, negative, 0, and undefined. Alright, now positive slope rises from left to right. Negative slope falls from left to right. A slope of 0 is that horizontal line. Okay, so when m equals 0, this is when you have a 0 in the numerator. Okay, then you have a 0 slope. An undefined slope is a vertical line, and that's when the 0 is in the denominator. Maybe you heard the expression before, Vux Hoy. So Hoy goes with the slope of 0. It stands for horizontal line. M equals 0. And it's a y equals equation. So any horizontal line produces a y equals, 2 or 5 or negative 100. Okay. Vux is for a vertical line. It helps you to remember that a vertical line has an undefined slope and an x equals equation. Alright, so those are our 4 types of slope. We're going to talk about today 3 forms of a linear equation. So I'll go ahead and turn this. So there are 3 ways we can write a linear equation. And you're going to have to be able to write all 3 forms and kind of manipulate any of these equations to look like another. Okay, so the first is slope-intercept form, which you are probably the most confident with and the most familiar with. Y equals mx plus b. So m, remember, is your slope, b is your y-intercept, and then x and y is a solution point. The next form is general. So we have general form here. General form will be the form that the book uses the most, so you're going to have to get used to it. It looks like ax plus by plus c equals 0. So everything's on the left side. There are 2 rules. A can't be a negative. And there are no fractions allowed. So if you get a fraction, you have to clear it, multiplying through by that LCD. The last form is point slope form, which is actually the easiest one. You can identify the slope and a solution point from it. With slope-intercept form, you can identify the slope and the y-intercept. General form, you can't really identify anything. So you're just going to kind of have to get used to that. Slope or point slope form looks like y minus y sub 1 equals m times x minus x sub 1. Okay, M is the slope, and x1, y1 is a solution point. This y and this x with no subscript there, this is just x and y in your equation, so those aren't going to change. Also, maybe make yourself a note, don't distribute the slope. We leave it factored out. That way we can actually recognize it. Okay? So we're going to do an example here where we're given an equation and or some information, and we're going to kind of manipulate it so we can put it in all three of these forms. Alright, so we'll call this example 1. Using the given points, determine the equation of the line. Put your answer in all three forms. Alright, and the first 2 points we're going to be given here are -4 and 1 and 6 and 3. Okay, so when you're given this, regardless of whatever form you're going to go into, you really need to find the slope. So I'm going to find the slope first. Remember, when you're finding the slope, it doesn't matter what order you start with, you just have to keep with the same order the same time. So if I start with the second point for y, then I have to start with the second point for x. So I'm going to do 3 minus 1 over 6 minus a -4 is going to give me +4. That's going to give me 2 over 10, which simplifies to 1 over 5. Now, I have the slope and I have 2 points, so right now I can already write my answer in point-slope form. So I'm going to start there. So point-slope form requires you to use 1 point and the slope. So I'm going to have y minus 1 equals 1/5 times x plus 4. Or you can write it as y minus 3 equals 1/5 times x minus 6. Either one of those answers is acceptable. And again, notice I'm not distributing my 1/5. Okay? So now that I have that, I have 2 options. I can either manipulate this and put it into slope-intercept form, or I can do probably what you've done many times, which is take the slope, y equals 1/5 x plus b, and then solve for b. So choose one of those points to substitute and then solve. It's up to you which way you do it. You can manipulate this or you can work with this. We'll just do this since I already have it set up. So I have 3 equals 1/5 times 6 plus b. It doesn't matter which point you plug in. So this gives me 6/5 plus b, which I'm going to have to subtract to the other side, but I need a common denominator. So I'm going to change this to 15 over 5. Subtracting the 6 over 5, I get b equals 9 over 5. So my slope-intercept form is y equals 1/5 x plus 9 over 5. The last one, you have to find general form. Now, when you find general form, remember everything has to be to the one side. So once I find slope-intercept form, now I go into general. So I'm going to move this y over. That's going to give me 1/5 x minus y plus 9/5 equals 0. Now remember, the rules say with general form that you can't have fractions for anything, so we got to get rid of that. And I have to have a positive a. So a is positive, but I got to get rid of the fractions. If I multiply both sides by 5 and I distribute to all of those terms, then I can clear the fraction. So that's going to give me x minus 5y plus 9 equals 0. And that's my general form, and it has to go in the order of x, y, and then your constant. Again, the book is going to put most of the answers in general form, so you'll sometimes have to check those. Okay? All right, let's try another one. So let's say we've been given the points 5, -1, and 5, 5. Okay, now right now when I see these 2 points, what I'm noticing is that I have this common x value. So this is going to be a quick problem, because if I think about the graph, 5, -1 is here, 5, 5 is up here. Well, if I was to draw the line, I now have a vertical line. I know with a vertical line I have an undefined slope. So when I go to plug this into the slope formula, you get 5 plus 1 over 5 minus 5. Well, what happens there is you get that 0 in the denominator, creating the undefined slope, therefore resulting in a vertical line. So I can actually go right into my equations now. There's not really, multiple forms here. So in terms of slope-intercept form, that looks like y equals mx plus b. Well, I have no m now. So this is just going to be x equals 5, because all along this line, x equals 5, okay? The only other form I can do is general, because with general form you have to move everything to one side. Well, I can do that here. I get x minus 5 equals 0. My x is positive, so that's good. My a value is positive. I have no fractions, so I follow the rules. You can't put this into point slope form because you can't plug in an undefined slope. So that question would be done. All right, we're going to talk about parallel and perpendicular lines. Okay, so hopefully you remember some facts about these. Parallel lines, and remember the symbol for parallel is like those 2 slashes. Okay, they have the same slope. So lines that are parallel are going to have the same slope value. Perpendicular lines, remember that symbol is an upside down capital T. They have opposite reciprocal slopes. Okay, so we're going to write some equations now based on that information. We'll call this example 3. Given 2x minus y equals 5, write the equation of the line through -2, -1. And we're going to do it 2 ways. A, it's parallel to the given line. And B, it's perpendicular to the given line. Okay, so a couple things. First of all, I am going to manipulate my given equation so that it's in slope-intercept form, so that I can recognize the slope right away. So I'm just going to do some manipulating here. So that means that my given line is really y equals 2x minus 5. If I bring over the y and subtract the 5 over, this is in slope-intercept form. And what I see now is that the given line slope is 2. So when I'm thinking about whether it needs to be parallel or perpendicular, I'm referring to the 2. So if it's going to be parallel, then I know that this slope has to be 2. So now that I know that, I have y equals 2x plus b. Remember, this b value is going to be different than the given b value. So now I have to use the given point that I know is a solution point of my line, and I have to plug it in. So I'm going to plug that in for x and y. So I'm going to have -1 equals 2 times -2 plus b. That gives me a -4. Add the 4 over, and I get b equals 3. So now the equation of the line in slope-intercept form is going to be 2x plus 3, and that equals y. And we know that's in slope-intercept form. If I wanted to change that to general form, then all I have to do is pull over the y. So I have 2x minus y plus 3 equals 0. If I was asked for this in point slope form, I could have actually started, or actually stopped once I got here, because I knew that the slope was 2 and a solution point was -2, -1. So I could have had y plus 1 equals 2 times x plus 2. I could have also started there and then backed my way into slope-intercept form and general form. So there's lots of ways to solve this. It just kind of depends with which form you're the most comfortable with. Okay? So now let's look at the perpendicular line. Okay? So again, going back to my original given slope, it was 2. I have to use an opposite reciprocal slope for perpendicular lines, so that slope's going to be a -1/2. Now I'm going to do this one different. I can still use this method where I'm putting it into slope-intercept form and then manipulating it, but this time I'll show you trying it the other way, putting it into point-slope form and then manipulating it from there. So I know that this is a solution point, so I'm going to start out with y plus 1 equals -1/2 times x plus 2. Now this is point-slope form. I'm done if that's what form they asked for. Okay, if I'm going to put it into slope-intercept form, then I'm going to have to distribute the 1/2. So I get a -1/2 x minus 1, and then bring over that one, and I get y equals -1/2 x minus 2. So here's my point slope. Here's my slope-intercept. Now, if I want to get it into general form, I have to move everything to one side. So I have -1/2 x minus y minus 2 equals 0. But I have two issues. First of all, I have a -a, so I got to get rid of that. And second of all, I have a fraction, so I have to clear the 2. In order to clear the 2, you have to distribute with the LCD. So what I'm going to do is take care of both of those issues by multiplying by a -2, and I have to distribute that everywhere. So I'm going to have x plus 2y plus 4 equals 0, and there's my general form. Okay, so depending on what you're most comfortable with, in my opinion, this way is way faster, how we did it in Part B, but some students aren't comfortable with that because you learned it more, plugging in the solution point and solving for that y-intercept. It doesn't matter to me which way you do it. It's your choice. Okay, we have one more example. All right, example 4. Suppose the value in 2001 of your computer, some of you weren't even born in 2001, was $850, and its value decreased $35 per year. Write an equation of the line. Let t equals 0 be the year 2000. Okay, so you're going to notice that this is actually our first word problem that we've had so far this year. Now that we're in the pre-calc book, we're going to see lots of these. So we're going to practice them in our notes, and you're also going to have to practice them in the homework, and they will be on future quiz and tests now. Okay, so a couple things I noticed. First of all, I know the cost of the computer in 2001. So in 2001, it was $850. Now they told me that t equals 0 corresponds with the year 2000. So that means that this is like an ordered pair. At year 1, it was $850. So I'm going to create this solution point. Okay? The next thing, let's label that solution point. The next thing they told me was that the value of the computer decreased $35 per year. This is the rate of change. The rate of change is the slope. So if it decreased, then it's going down, and therefore I have a negative slope. So my slope is a -35. So I have a solution point and I have a slope. I can plug it into point slope form right now and manipulate it. Let's put our answer in slope intercept form. Or I can plug my point in and solve. So that's what I'll do. I'll do y equals negative 35x plus b. I know that my slope is negative 35 because it's decreasing $35 per year. Remember, this is my x and y, so I'm going to substitute that in. I get 850 equals negative 35 times 1 plus b. If I add over that 35, I get b is 885. Now this means a couple of things. First of all, I have enough information to write my equation. So y equals negative 35x plus 885 would be the model for this situation. I also know then that the computer was worth $885 when I purchased it, okay, because the year 2000 was 1 year prior. Now, this question was pretty easy. You didn't really have to plug all this in, right? You could have really backed in to that original value because only 1 year had passed. So for this particular problem, if you didn't have a ton of work, I would understand. But in the future, you want to try to create that solution point and look for that slope in a linear situation. And that's all of 1.1.